Hello there, calculus. Welcome back. We're going to do some Newton's methods problems on a spreadsheet, which I think you're going to like a lot better than doing it on a calculator. And the problem that we're going to be doing, I know it might be a little hard to see right here. I'm going to do number 426 from this section of the book. And the equation it is trying to find the zeros of is x minus 5 cosine x. So actually right over here, I made a graph of the thing. This is the graph of f of x equals x plus 5 cosine x. And what we're going to do is we're going to try to find one of these zeros of the whole thing here. Okay, you can see the equation appears to have 3 zeros. And just for the sake of argument, let's choose that we're going to try to find this one, okay? So we're going to use a spreadsheet to do this here. And we're going to need to work through how all of this works here. So I got Xavier's next to me here, and he is promising to be quiet while I'm recording this. Let's see how that works out. All right, so we're gonna make a spreadsheet. Now I'm gonna do it over here. I know spreadsheets aren't exactly everybody's thing, but we're gonna try to work this through here. I'm gonna make a column called N, just like we did when we did it on the whitey board. And we're gonna have a, did I have caps lock on? What's going on here? Oh, I see it, because this is so large, okay. X sub N minus 1. So like, for example, when we're working on our first guess, we're going to need to know x of n minus 1 or x of 0. That's going to be our initial guess. Let's see here. Well, we know it's really somewhere near negative 1.3. Why don't we say negative 1? Our original guess will be negative 1. So negative 1 will be our initial guess. All right. We need to know the value of f at x sub n minus 1. So what is f again? It's 5 plus, no, I'm sorry, it's x plus 5 cosine x. So let's write that function in here. It's equals 5 plus, I'm sorry, no, equals x. This is our value of x plus 5 times the cosine of that value of x. Put that in, and we get f of x sub n minus 1. All right. It is the value of the function f of x at the value x equals 1, negative 1. All right. Now we need to know the derivative of that function. The function, again, remember, here, let me just write it real quick, was x plus 5 cosine x. And the derivative of that will be 1 plus 5. Oh, derivative of cosine, oops, sorry. 5, and this will be minus there. That's what the derivative is going to be. So actually, let me just rearrange this here. Let's put this one over here so we know what's going on, and this one over here so we know what's going on. Okay, so f of x is x plus 5 cosine x, and the derivative is 1 minus 5 sine x. So the derivative at x sub n minus 1. If you don't know, by the way, the symbol underscore usually means sub. Like that's how you write subscripts. All right. So this function needs to be 1 minus 5 times the sine of x, x of n minus 1. There we go. That's our value of f prime of x. So then Newton's method can give us x sub n. X sub n, remember, was x sub n minus 1 minus f over f prime. And that gives us our next guess. All right. It surprises me that it's a negative number, but oh no, it doesn't, that makes sense. Okay. All right, so now we have our first guess here. Guess x of n, when n is equal to is equal to 1, means x1 is equal to this. It is closer to the correct answer than this was. All right. Now let's make guess 2. Now, honestly, you could sit here and go 1, 2, 3 like this, but let's get a little smart about this. Let's use functions. If we want to make x plus 1, we want this cell here to just be this cell plus 1. Now this cell is equal to 2. All right. What is x sub n minus 1? That will be x1. Well, I don't want to sit here and just type this thing in here. Instead, I'm going to say it's equal to this cell. That way I just copy that value over here like that. All right. Plus, if this value over here changes for some reason, this value will change. Why would that value change? What if I chose a different guess over here? See how the numbers all reflect the change? Yeah, pretty slick, right? All right. Now, for this cell, we need f of x n minus 1. Well, actually, we can just copy the formula here and paste it down here. This is now f of this value. And for that matter, This is now f prime of this value. And this is now x sub n, where n is equal to 2. So this is our second guess. And in fact, now we could probably just copy and paste this down, paste it again, and paste it again. And look what's happening here. We're getting closer and closer to negative 1.0644 or whatever as our solution here. And notice how f of those numbers gets closer and closer to 0. In fact, it gets to within, the rounding error, it's so close to 0 that it can't tell the difference to 0 after only 5 iterations right there. So we know that the actual 0 of the function is at negative 1.30644 or whatever, which makes pretty good sense for this function right here, right? That seems like it could be. Hey, how could we find this 0 over here? Well, let's just choose a guess near this 0 and see what happens to our spreadsheet. So let's choose, well, let's see, we know it's around 1.9. Let's guess 1.5. If our initial guess over here was 1.5, look what happens to our spreadsheet. In just a few iterations, it gets to the solution of 1.977, which I think is correct, yes. And for that matter, we could get this solution over here, which is at 3.8. Let's guess 4. We'll change our initial guess to 4. And look what it did. It found us to that solution of 3.877467106. Newton's method rocks. This is a slick trick for finding a derivative. Doing it in a spreadsheet is an awfully slick way to do it versus doing these problems on paper. And if you do them on spreadsheets, go ahead and, whether you're doing it in Excel or you're doing it in Google Spreadsheets, either way, you can do it the same way. You can rename this sheet something like problem, I don't know what we were on there, 442, let's just say. And then you could add another tab and you could just turn in one spreadsheet workbook or whatever they call them to me. You'd have all the problems on the same one. Let's see if we can find another one of those here. That's the only one I actually had made for you in advance. But let's take a look at the problems here. I'm gonna come back to that. Let's take a look over here. Here it is about finding the maxima and minima of these functions here. One of these is what I did in the, in fact, 442 is the one I did in the earlier video. Well, how about this one, number 440? Minimum of f of x equals x squared e to the x. Let's take a look at what that function actually looks like first. I'm going to bring up a Desmos window here. And, oops, sorry, I didn't realize I tipped the screen right there. And we're going to need f of x equals x squared e to the x. Ooh, and what is it asking for? You're going to be quiet over there, little guy. And what is it asking for on problem 440? It's asking for the minimum. So it's looking for this value right here, which looks suspiciously like it's going to be at 0, 0, but you just never know. All right, so on our spreadsheet, we're going to need a column for n, x sub n minus 1, f of x sub n minus 1, f prime of x sub n minus 1, and x sub n, just like we've had before. Our original function over here, just to keep it straight, is x squared times e to the x. We're going to need the derivative of that. All right, so let's see here. It's a product rule. So it's going to be 2x times e to the x plus x squared times e to the x. Hey, we can even simplify that a little bit. That would be e to the x times the quantity x squared plus 2x. Okay, so you can solve that for yourself and decide that that's correct. All right, our first guess, when we're working on we need to have the 0, the initial guess. Let's take a look over here at this. Again, we're thinking that the answer is somewhere near 0. Let's guess it's at 1. Okay, so we're going to guess that the solution's over here someplace, and then we'll see if it walks us toward the right answer. All right, where am I? This one. So x sub n minus 1, our first guess will be 1. All right. Then our function f of x sub n minus 1 is x squared e to the x equals this thing squared times e to the x. If you don't know, e to the x can be written exp of x. It gives us that. Hey, that's e. That's interesting. That makes sense, actually. And then f prime is equal to exp of x times the quantity x squared plus 2 times x. All right. Hey, I'm going to send you guys this spreadsheet, by the way. All right. And then x of n, according to Newton's method, is x of n minus 1 divided by, minus f divided by f prime. And I get the new number. Hey, notice, by the way, that the new guess, x1, is closer to 0 than x0 was. Perfect. All right. This one is just this number plus 1. This one is just this cell. The rest of these actually can just be copied. Oops. All right. Hey, we're getting closer. 3, 4, 5, 6, 7. Still got answers that aren't terribly close to 1. But as we're getting closer, look how the f of x's are getting closer and closer to 0. In fact, at some point, we're pretty much convincing ourselves here that we are approaching, like, for example, our guess x16, our 16th guess, is 0.00003, which is pretty damn close to 0, right? So the solution here is going to be at x equals 0. This is pretty slick, and this can be used to solve all kinds of problems. And I thought I would actually bring up something from the distant past here. Remember when we had that animate and orbit problem that I was showing you, and everybody was getting a good chuckle out of my stupid program here that was trying to animate orbits? Because remember, originally the orbits were, the planet would kind of rock back and forth and do all kinds of weird things. It turned out there was a step along the way where you had to determine what's called the eccentricity of the orbit, and I had a problem with it because I hadn't used Newton's method correctly. But in fact, if you dig through over here in Desmos, where I wrote all the code right here, solving for the, it wasn't eccentricity, it was true anomaly using Newton's method. And it's a little bit different how I work through the steps here because not everything is trivial in Desmos to get things to work. But like this equation should look familiar to you. Our first guess of the eccentricity will be our initial guess minus f over f prime. And in fact, you can see that then our second guess was equal to the first guess minus f over f prime. And we had to repeat that process, I think, 3 times to get it I had to repeat that process enough times to get it to work to there. And see how if I mess with this here a little bit. Now I get nice behavior because I now have it correctly determining what's called the true anomaly of the orbit using Newton's method. And it works beautifully. I'm so proud of myself for getting this to work. And it only took like an hour once I realized what I was doing wrong. All right. You guys should have lots of fun with this. I can't tell you not to do it on paper, but I'm telling you, you're going to be a whole lot happier using something like a spreadsheet to solve the problems on today's assignment, okay? You're just going to be a lot less error prone and so on. I love helping students with problems with spreadsheets. If you need any help with this, please let me know. And stay safe out there, all right? Let me turn this on. Hold on.